Hello. In this video, we are going to derive Graham's law of effusion from the principles of the kinetic theory of gases. First, we assume that we have two different gases in a container, gas A and gas B, and that they are in equilibrium. Therefore, since they are in thermal equilibrium, they have, by the kinetic theory of gases, the same average kinetic energy. So the average kinetic energy of A is Ke sub A, with a line over top of it to show that it's the average, is equal to the kinetic energy of B, average. Next, we use the formula that the kinetic energy is equal to 1/2 mv². So on the left-hand side, we put the appropriate subscript, so we have the mass of A times the velocity of A squared divided by 2. That's the kinetic energy of A. And then m sub B v sub B squared over 2 is the kinetic energy of gas B. Next, we multiply each side by 2 to get that m sub A v sub A squared is equal to m sub B v sub B squared. Now, if we divide each side by m sub A and v sub B squared, we get that v sub A squared over v sub B squared is equal to m sub B divided by m sub A. If we take the square root of each side, we get that v sub A divided by v sub B is equal to the square root of m sub B divided by m sub A. Next, we can multiply the right-hand side by the number 1 in the form of the square root of Avogadro's number divided by Avogadro's number. So note here that the subscript A refers to Avogadro, whereas the subscript for the red symbols is for the gas molecule type A. Now note, if I multiply the mass of one gas molecule A by Avogadro's number, I get the molar mass. So this is a slightly different m, written more as a script. So here the m sub A refers to the molar mass of gas molecule A. Similarly, if I multiply the mass m sub B of one B gas molecule times Avogadro's number, I now get the molar mass of B. So now we see that the ratio of the velocities of A and B is inversely related to the square root of the molar mass of B divided by the molar mass of A. Finally, at the point of effusion, the gas molecule A inside the container and outside the container are in thermal equilibrium. So they will have exactly the same velocity by the reasoning that we used up here. So we can replace V sub A by R sub A, where now R sub A is the rate of effusion of gas molecule B. And by the same reasoning, since the gas molecules B are in thermal equilibrium before and after effusing, the velocity is exactly equal to the rate R sub B. So we get our final conclusion here, Graham's law of effusion, that the rate of the effusion of A divided by the rate of effusion of B is equal to the square root of the molar mass of B divided by the molar mass of A. I thank you very much for your kind attention. Stay safe, and as always, have a good one.